So let's go ahead and see how we can create a singly linked list in C. Okay, so we'll say singly linked list in C. All right. Let me go ahead and include, I'll say the stdio, and we'll include stdlib. Okay, and there's our int main. Right. Our linked list is going to be composed of nodes. So I'll have struct s node. All right, I'll just call it node for now. Node. And we'll type define it as node t. So we'll say type that. And then we'll have some data. And then we'll actually have a pointer to the next node. So that's how it's going to be linked. So let me give you an example. Right? I can say, well, let's make first a something that will make us the node, like a constructor. So we'll say node t make node, and then we'll say int value, and here we'll say node t star node equals node t star malloc size of node t. All right, then we'll say if node is null, so if we couldn't allocate the memory, we'll just return null. Otherwise, we'll say node data equals value, and node next equals null, because it's not linked at this point, right? And I'm going to go ahead and return the node here. So we'll say return node. That's our make node. Let's go ahead and we'll write a print node function. So we'll say void print node, node t node, and we'll say if the node is null, we'll just return. Otherwise, we'll print f just this, maybe a space, and we'll say node data. All right. So let's go ahead and maybe bring this up a little bit. All right. And we'll say node t first node equals make node 10, and node t there second node equals make node 20, node t third node equals make node 30. And then I'll say first node next equals second node, and second node next equals third node, and third node, just to be explicit here. All right, so I've linked my my three nodes, and then I can go ahead and write a print list function. So maybe we don't really need the print node here. Let's convert this to print list. All right. All right, and we're going to use the an iterator approach. So we'll say node t iter equals node, while iter doesn't equal null. We're going to go ahead and print iter data, right? Because iter is pointing to our current node, to our whatever we passed in. So we're gonna print the, oops, whatever it's pointing to, and then we'll say iter equals iter next, right? That's how we're gonna iterate throughout the list. So it's gonna be first node, then print it, it's gonna next, so next of the first is the second, not now, print iter equals seconds next, which is third, print it, third equals thirds next, which is now, so we're done. And we'll just printf a new, we'll just print a new line out here. Okay, and at the end, we're gonna go ahead and say print list first node. All right, this looks good. Let's go ahead and GCC, so we'll GCC example, not example one, but I think I called it S list, there we go. Oops, I said print, this should be print F, not print. No, that's print in function print list. Oh, right here, print F. There we go. Okay, let's try this again. Oops, I compiled the wrong file. Okay. 10/23, perfect. Okay, however, if I end up running Valgrind, it's going to tell me that I lost 48 bytes in 3 blocks, right? So the 48 bytes, I have 3 nodes, so 48 divided by 3, what is that, 16 bytes? 16 bytes, so the size of the node is 16 bytes. If I do a full summary here, so let's say if I use the option that Valgrind gave me here to check with full, I'm gonna put that here. Okay. Seems that all of them, yeah, all of them are coming from make node, which makes sense. Okay. So I have to go ahead and free my list. So we'll say here, oops, let's scroll down a little bit, there we go. So I'll say void free list node t node, and kind of similar idea as before. So I'll say, hey, if the node is equal to null, then we'll return. Right, so we'll say while iter doesn't equal to null. I have to be careful how I end up doing this, because I can't do this. I can't say free iter and then iter equals iter next. This wouldn't work because it's undefined behavior. If I free the iterator, which points to the first node, then I say, all right, the iterator will equal whatever is currently the iterators and then next. But whatever is the iterator, I freed. So this is trying to access here, this piece of code will be accessing this pointer here on a deleted memory address. So essentially, to fix this, I have to say something like temp equals iter next. So I have to remember, or I can just maybe to be more descriptive here, I can say next. And then I free the iterator, and then I set the iterator be equal to next. So this way I don't access memory that has been freed by accident. So at the end here, we'll say free list first node, and that will free the entire list. Let's go ahead and try this again. Oops. All right, 10, 20, 30. Let's go ahead and run it through Valgrind. And it says 3 allocation, 3 frees. So we're not leaking any memory now. Now at this point, you'll notice that this is not truly a list, because if I wanted to like remove the second node, I have to do well, I have to write something like this. Node T, I'll say remove node, and then we'll say here, we'll just call it remove node T node, and then we'll say int position. So here we'll say, hey, if the node is null, we'll just return. We'll return null, we won't return anything. And then we'll say, all right, for int I equals 0, I is less than position, I plus plus. And then we have to start at the first one, right? So we'll say node T iter equals node. Actually, I don't even have to start. I can start at the after the first one, right? And I can say node equals, oops, I'm sorry, iter equals iter next, right? So doing this is going to be a little tricky because I only point in one direction. So I do something like this, right? I do 10, 20, 30, and then I say no. So if I want to remove 20 here, okay, doing it in the main is going to be pretty simple because I can just say first node next equals third node, and then I'll say here free the second node. Right? So I've relinked the first nodes next. So essentially, let's move this down a little bit. Essentially, I started with 10, 20, 30, and then no. So this was our first, second, third, and then I say, hey, the next of the first is going to be the third, so I'm kind of removing the second here, kind of like this, right? This is how it will look like in a if I did it directly in main, but doing it in a loop, doing any at any position is going to be a little more tricky because if I iterate like this, I will get the node in question. So when this for loop is done, say I was trying to remove 20, so the position is going, well, depends on what we pass for position. If I pass it position, if this is position 1, right? If this is a position 1 here, then iter right? Position is 1. I started 1. So iter here is going to be pointing to this node. So now I have to figure out, all right, this is the 20, but I have to point to 30. So I have to say, all right, give me the next is next and link to that. So I'll have to do something like this. So iter here, I can kind of remove this, and I'll say node to remove, and we'll change this here to node to remove. Node to remove. Right. And then now we'll say node t new next node equals node to remove next, right? And then now that I know which is the next node, I can pretty much free the node to remove. And then I'll say, well, in our case, the node to remove is that, well, if we're removing at position 1, I'm sorry, for position 1, the node to remove is actually going to point to, okay, let me rename this because it's a little bit misleading. It's not node to remove. It's actually node to relink. There we go. Node to relink. Node to relink. All right. So now I'll say node to remove equals node to relink, right? The next one. And then now I'll say node t new next node. It will equal node to remove next. So now I'll free the node to remove, and then I will say node to relink next equals new next. Okay. Right. So let's take an example of see how this will look. So if I have 10, 20, 30, and then null, and I'm trying to remove 20, so position equals 1. All right. In our case, since I start with the first node, I'm not going to enter this for loop, so node to relink will equal the first node, 10. And then node to remove is going to equal 10's next, which this results in 20. And then node new next is going to be node to remove next, so 20 is next, which is 30. And then lastly, node to relink, which is 10, is next, is going to equal 30. So essentially, we have gotten rid of the 20 there and relink 10 to 30, and there we remove the 20 here. Now, this will work in this scenario here when we have, right, so it will work in this scenario. But what about if I have a scenario where I'll only have one element, or I'm trying to remove the last element, right? In this case, new next will be null. Right, so it might get tricky. There's a lot of edge cases here that I haven't handled. Okay, so I just want you to be aware of that. I'm just showing you how the linking will work. And then lastly, I have to return the node to relink. So now I can go ahead and get rid of my removal here. And I'll say first node equals remove first node, and then I will say position 1. Kind of afraid to run this because I don't know if it will crash or not, but let's give it a shot. Alright, so I'll come here, say clear, we'll see GCC slink. Okay, we have an error somewhere. Okay, so let's handle this error first. It seems like there is a previous declaration of remove in stdio, so I cannot use the remove name. Unfortunately, there's no straightforward way to use namespaces in C like we have in Java. So I'm going to go ahead and say remove node here. All right. Of course, you could do this recursively, but it's going to be a little more challenging. And I know the other error here is that if I use GCC doesn't like having this in the for loop after declared outside. So I'm just going to use clang in this scenario, because if I run GCC again, why is it still complaining about remove? Maybe I didn't save the file. Let's try that again. All right, yeah, so the other, I say, hey, in this standard, you can declare variables inside of the for loop. So either use clang or use pass the different standard to GCC. So I'm just going to use clang. All right, let's go ahead and run this. 10:30. All right, good. Let's val grind this. Good. All heaps were freed, etc. All heap blocks were freed. So obviously now you would ask, well, Vito, do we develop the whole program in just one giant file where we put everything? Do we put all the functions in just one file? And do we have to deal with these nodes? What about an ADT or an abstract data type? What I'm trying to say is we need an enclosing class or a wrapper class that will handle some of the details for me, so I will not have to do things like this, for example. So I will stop this video now, and in the next video we'll see how I can write this as an abstract data type, or within a class, so to speak, although there's no classes in C. All right, thanks for watching. I hope this made sense, and I'll see you in the next video.